Welcome to Brain Vision.
For this problem, we're going to be looking at a hyperboloid of one sheet. We're given the following equations that were given, and we ultimately want to show that the parametric equations represent a hyperboloid. So, with that in mind, we're going to first divide both sides of the equation by a, the first equation, and square it. So we'll end up getting x over a squared equals cosine h squared u cosine squared v. And then we'll have y over b squared equaling cosine squared u sine squared v, and then z over c squared equals sine squared u. So then ultimately what we'll get is that x over a squared plus x over, or y over b squared will end up giving us cosine squared u. And then when we subtract this right here, it'll give us a cosine squared minus sine squared, which it's sine h squared cosine h squared, because this is h and this is h. So ultimately what we'll end up getting is 1. And that right there is the equation of a hyperboloid of one sheet. So that's satisfied. And then for part B, we want to plug in a being equal to 1, being equal to 2, and c equal to 3. So with that, we get the ellipsoid x squared over 1 plus y squared over 4 minus z squared over 9 equal to 1. We won't be able to graph this perfectly, obviously, but we can at least show a general idea of what it'll look like. And it'll look something like this. So that is our hyperboloid that we'll be looking at, and this is round 2. So there's this space inside, and it looks something like this, with also hyperboloids like that. So that's our figure. And then lastly, for part C, we want to set up an integral. So to do that, we first want to take our partial derivative with respect to u. So that's going to be sine h cosine v 2 sine h sine v and 3 cosine h u. Then our partial derivative with respect to v is going to be negative cosine h u sine v 2 cosine u cosine v, and then 0. So then when we take their cross product, what we end up getting is a negative 6 cosine squared u cosine v. Then I will get a 3 cosine h squared u sine v. And then we'll get 2 sine h u cosine u. Then we'll take magnitude of that, and ultimately our point in doing that is to find the surface area. So our surface area is going to be a double integral. Since z is from -3 to 3, we have that this is from 0 to 2 pi, and this will be negative sine h, the inverse of that, and this is sine h inverse of 1 cosine h u times the square root of 27 cosine h squared u cosine squared v plus 9 cosine h squared u plus 4 sine h squared v sine h squared u, and that's du dv. And that's our final formula for it. We don't have to evaluate this, so this would be our integral as a result.